Hi everyone, in this tutorial I'm going to show you a little bit more about fluid simulations. We select the cube and we're going to enlarge him a little bit like that, and X direction also. Make a big container, a bit more like that, and let it grow probably in Z direction also a bit like this. Okay, we move it a little bit outside and we're going to wireframe mode. This is over here so we can see what's happening inside. We're now going to prepare a few things before we start, and we're going to add another cube, largening a little bit also, and we put it inside. Pay attention that it might not be bigger than your container, so I will SY, make it a little larger like this, and we're going to put it on the corner so you can see it very nicely maneuvering. Okay, it's looking good, it's inside. Okay, good. Now I'm going to add a few other parts. Mesh, say cylinder. Okay, I'll put that one over here, and we're going to Control D, copy another one, and we're going to put one over here. We're going to put them also in the box like that. 3, mount it a little higher, this one also. And these I'm going to use as obstacles a little later, but I already had add them inside. Okay, I'm going to put it a little downwards like this. Okay, yeah, I think we're approximately ready. Good. To start with the simulation, on the right screen you have that button, and this is the simulation mode. We are on camera, now you can't see anything, but if we select the cube we get all sorts of different simulations we can do. We are now interested in the fluid simulation, and what we're going to do now is, first of all, we're going to say where everything is going to happen, and everything is going to happen in the cube. And that's the only part that you can use. Thus, we're going to say to here, this is the domain, and domain means that every fluid drop happens to stay in that box. It cannot get out, and you cannot choose another object. As you don't try with sphere or with cone or anything else. The cube is the domain. What's important here is, first of all, the resolution. This resolution is the resolution that you see on the final rendering. This is that one, and this is the one you see when you render, when you bake, and you see the simulation running. Thus now it will be 45. The higher you get that number, the more megabytes it takes, and the more baking time it takes. So the result will be much better, but the baking time will take much more time. So I leave it up to 65 for the moment, but later on, if you're running your simulation and it runs okay, then you could get higher with it, and better volumes of higher volumes, and give a better result. Pay attention, save first, otherwise it can be happening sometimes that if you put too much over here, the baking time is getting in trouble and your computer is going to crash. So it's better to save. The next thing we're going to do is, this is the animation area where we have 0 up to 250 increments. I'm going to decrease it to 100, and over here you said that the start is at 0 when we start at 0 increments, and the end 100 increments is 4 seconds. And another thing that's important is, if you have a very fast drive, you can say over here to put that drive so the calculation will be more rapidly. Underneath you have fluid world, where importancy is that viscosity. Thus if you have certain values for oil inside already pre-programmed, water and things like that, this depends this simulates the thickness of your material. If you have other thicknesses of viscosities of materials, like for instance chocolate or something like that, you can find it in the internet. This is the real measurement of every size of the piece, but this is not important. And last two, the last one is particles. This is very important if you make difficult simulations, but not now. And this has to do with the boundaries. As if your material is knocking to the outside, this in this case the cube, you may have partial slip. This is meaning that material can slip or no slip on the boundary. You can play around with it. But we are here to start up, and we're going to select that cube, and we're going to say that that cube is filled with fluid. Okay, I don't change anything. We're selecting that one, and we are going to bake it. Now you see that the fluid box is filled with water, or what I've chosen there, over there, and we are at step 1. If I press step 2, you will see directly that the water is coming out of the box underneath and flows open. If I go very fast, you will see that at a certain point, if I am quick enough, I'm picking that one because it's faster. Yeah, there's nothing happening over here. No, he's still simulating. Thus, don't panic. If this is done, you run your simulation with that button. Yeah, the simulation starts, you see. Stop, go back forwards and play around with it. Stop, go step by step. This is mainly the base of the whole simulation. What we can do now is we're going to add one by one these particles. And I'm going to say to that one, this is an obstacle, meaning that if I now let the cube render, select the cube again, if I now bake it, let's say it like that, correctly, and I let it run, I go to 0, I go step by step, you will see that the material is going around, not around this one, but around this one. See, he goes through that, but he knocks on that one, you see it better from the top, he goes around it. See? He will touch it. Now we go back and we do the same with the other one. Select that one. I'm going to say fluid obstacle. And we do the same. They both are obstacles and the water is flowing left and right. You see that at the end of the simulation, I'll put it at the end of the simulation, there's a not high amount of water. This is why there is no extra inflow of water. There's the water that's in the cube and not more than that. Okay, we're going to change that and we're going to put that one not as fluid but as inflow, meaning that the water will constantly flowing, and it will flow until first of all your time is passed, or secondly that your cube is filled. Now we're going to select the big cube and we rebake it, and we're going to see what's happening now. So you see that there's constantly, and if I'm going too fast, there's constantly water coming in. This is still calculating that it won't be finished. And why is it going so slowly? Well, because I didn't put any speed on it. So I will change that. Okay, go back. We're going to select that box and going to say I want a certain speed. You can, Z speed is up, is that direction, X speed is that direction, and Y speed is that direction. So for instance I say -2, and then the water will flow like this out, and I say -3 and -2, and it will do something like this, splash something like that. Go to the cube, bake it again, and now you see the difference. Go to step 1. You see, it's coming already that direction and a little downwards. So it flows again and above and over these things. Why? Because they're little obstacles. And you see the whole box will be filled in a few seconds. Go back, see. Why? Because of the speed. And then stops. It will be stop somewhere over here. You see? Everything is filled, but you see that the two pieces are not filled because there are obstacles. Why is the shape here not completely round? But this has to do with the final result. I'll stop the film simulation. I put in here 100 and you will see that it gets more. Put it at 0 and we're going to set it also at 100 so you can see it better. You see? No, it's calculating, it's not going that fast. You see that the material is in much more smaller particles. But this is so if you're done with the baking and the baking is good for you and the final result is okay, now you can go to the animation. Pay attention, switch here to AV JPEG or another file you want. Select the correct temporary file, and you do when it is done, of course. You already see it coming a little. It's not correctly positioned, but okay, we'll show you in a few seconds. I reposition the cameras and I let the animation run, but it takes some time. He's still rendering, you see it over there. I have just a limitation of 15 minutes, so I will stop the video and then come back. So you see a few steps already, but then I put on the internet directly the results at the end. You see he's calculating still, but we're at that position. So if this is done, then you have your AVI file ready and you can have a quick look at it. Thank you for watching. Bye.